Okay, I think we can start. Maybe let's start with art and then go up.
Yeah, hey guys, really interesting read today. I spent most of my time kind of struggling with the layers of abstraction that are relevant, and along the lines of the question I posted in the chat, why use libp2p versus others? And my investigations brought me to comparing libp2p versus secure scuttlebutt, SSB, and it seems pretty obvious that SSB puts on a layer of privacy that's not necessary in this case. And then I tried to investigate things built on top of libp2p, which give you other things that are useful on top. And the thing that kept on coming back up was BitTorrent, which has two interesting concepts. One is called tit for tat game theoretic enforcement, where the decentralized operators provide value only as long as the counterparty continues to reciprocate. And there's another one, another concept called, sorry, I lost it. Event-based signaling and tracking, which allows on protocol the delivery actor to signal that they've done their job, and the paying actor to signal that they would like to continue to pay or to continue to receive this service. So I was just observing that libp2p solves like some questions about the transport layer or the communication envelope, but it seems there are really interesting, sorry, more interesting to me questions above that about how a robot can deliver a service and have the paying actor be happy that they sent some money out into the ether or some value out into the ether, and that that thing was actually delivered, and it's useful to possibly layer on top of existing well thought out protocols to enable that. And yeah, that's where I ended up. Thanks.
I think it's Ben.
Okay, yeah. So, I mean, I guess I have a little bit of a libp2p story, and that is, so I'm working on a project that's supposed to, actually have a peer-to-peer network involved, and um, I originally wanted to use libp2p, but I didn't quite understand what it was pretty complicated, and I ended up, implementing something else that was, I think, actually a lot worse. And eventually I came to regret that. And actually, what happened was, just last year at sort of the end when, Claude was power and the AI tools were really powering up. One of the first tasks I gave Claude was, hey, can we, remove this whole thing and just implement peer-to-peer instead? Um, and that actually worked really well. And, so far libp2p has been quite good. Um, so, I guess, yeah, that's what ended up happening. So it took like an AI for me to actually fully understand what it was trying to do. But at the end of the day, was able to implement it, and it does definitely feel like it works better than whatever the old library I had before. Um, yeah, it's I getting the abstraction level right for this networking stuff is very difficult. Because I originally was maybe put off a bit from the P2P because it seemed like it was so trying to do so much, and I wasn't sure that was actually necessary. But I think looking at it back later, it actually I think fits in a really good place of it doesn't pay too much attention to how the peers actually interact, but instead sort of just tries to maintain an identity system and handle the connections and so on. Um, I've heard like it was actually I'm running into a problem with like getting development, but hopefully that between AI tools and just it's quite popular I've heard. Then hopefully it can get what it needs. Anyway, I think I'll pass it up then to Anraj.
Yeah, so I didn't go into the technical details how it's implemented, but I was more looking into the history of where it came from and then how it relates to BitTorrent. It seems like the BitTorrent is much lighter, spec than libp2p, and but with less flexibility. So we basically I was like we have been looking into peer-to-peer protocols for the Yakrova project, and then like we are using ESP32, and then there is a specific mesh protocol called ESP mesh that is provided by the vendor company Espresso. But then the peer-to-peer protocol actually becomes very vendor dependent. So basically I was trying to find some alternatives, and dev p2p and lib p2p were like one of the like were the options to look into. So yeah, so I was like just chatting with Claude, like what are the things required to implement lib p2p on a resource constrained device like a microcontroller. And it seems like it is quite a heavy protocol to implement all of the stuff, but maybe something lighter can be implemented on microcontrollers. And but yeah, the one thing that I kept wondering was like, why does the execution layer have a different peer-to-peer protocol than lib p2p, and it's something called dev p2p, it seems. um, yeah, so those were some initial thoughts, and I don't know if Jenna wants to chime in. Seems like she's on listen mode, but yeah, the floor is open if somebody wants to have has some more comments. Artie, are you on mute if you are trying to speak?
Okay, yeah, I guess it would be useful for me to hear from you, Anuraj. What what is the flexibility that you see in rewrite in writing something on top of libp2p as opposed to building the interaction set on top of a higher level abstraction such as BitTorrent or some smart contracts surrounding X402, like and where my mind went with this, like thinking about this for 25 minutes, was the question of escrow or provability or satisfaction of some action that someone pays for. I'm just curious to hear what questions you've answered already.
Yeah, so basically, like, so yesterday, yesterday we had some discussion about this with Rafa, and like how do robots deliver data. So he was trying to find some way to. So he's trying to implement the Yakro protocol on some drones, and then it has like large files. And then he was just wondering how do you deliver that. And then we also had previously had some discussions regarding this. Like at least there is a guy called July on Farcaster, and he was with us for one of the meetings, and he was saying that at least in Waymo, what it does is like they go to some data hub and deliver all that data. So I was just wondering, like, if we don't, so IPFS is like kind of one solution to it, but then what we are doing is like implementing a lot of the stuff on the lowest resources possible, possibly on a microcontroller. So discovery is one thing, so you could do that with ERC8004, but if you are on a local network, then like how do you do discovery, right? So so lib p2p kind of helps in that. So right now we are using mdns there, but I think lib p2p I saw somewhere like it's also working with mdns. So I am just exploring the various things or the different stacks here, so what we could use. uh, so right now I myself don't have much idea of like what I want to implement, of what or what it would be useful for. Yeah. But like distributed data storage is obviously one thing. So I've seen some implementations of IPFS on microcontrollers, but they are kind of let's say libraries expecting compute other compute nodes who have like much more storage or compute resources. So if you want to have like a small mesh network, like if I have like 4 5 rowers with ESP32 microcontroller brains, then how do they find each other? So right now the only solution I have seen is like the ESP mesh, but it's really vendor dependent. So it's provided by the Espressive company which sells ESP32.
Yeah, that's a useful framing. Um, when I was reading the libp2p overview, I think the discovery aspect I found, or I was happy to consider that to be mostly solved. And then it was the accountability aspect, which seemed less obvious for robots specifically, because most of the things built on P2P networks involve the delivery of data rather than the delivery of an action in the physical world. As you were speaking just now about IPFS, I was thinking originally that the robot would need to take a screen, a video cap or a picture, and then post a link to that, provide a link to that picture to the payer as a proof that they did some micro action. But then there's another pathway to providing accountability, which is that yeah. So hear me out. This is half formed. Um, within the Yak Rover protocol, you could say that every compliant robot in the protocol um, posts a proof, a proof in air quotes, which could be just a timestamp of delivery of the action. And so then all all you have to do to provide proof is not like a whole IPFS blob, but just a small compact piece of data, uh, which could be as simple as a timestamp. And then the reputation would need to be mapped somehow into some verifiability of that action and that timestamp, which can be optimistic. You say, I trust all compliant, all actors that post protocol compliant messages. I trust them by default. And then later on, if I find that someone is cheating and stealing money, then their reputation gets marked down. And that can be somehow handled within the protocol, with within the reputation systems that are in the protocol already, as well as the mechanism of posting this compact proof. So that's just where my mind went. Not sure if
Yeah,
that's
interesting
useful or not.
direction because about the embodiment and affordances in themselves. So, like these days, like the middlewares used in like the glue code that helps the robot parts to communicate with each other is basically like the ROS is a protocol kind of a middleware. It's the standardized one. So there are a few others, but it's mostly the market is owned by ROS. But it's not, I think, designed for this verifiability or trustworthiness. So I think like there is some space for improvement there, or like some things could be used from lib p2p. I actually don't know, because like we have been like, Venkat talks a lot about this scavenging robots, right? Basically, like if you have like a robot brain, and then if you have seen Rick and Morty's pickle Rick, so he basically evolves from a pickle to different kinds of animals and by scavenging different parts. So if like if you could broadcast and in a peer-to-peer way of the like the affordances, different affordances that robots have, they could combine together to form different kinds of robots. Like those, yeah, that was the thought that came off from the discussion you started.
Yeah, that sounds really natural. Like if I pay a really basic robot to scavenge and develop some skill that they can then advertise after, you know, attaching that piece to itself, like I have some confidence that it actually delivered the first step. And then eventually I pay for it to go and, let's say, push a button somewhere or turn something on. And then I independently verify that the thing that it turned on starts broadcasting to the internet. And then I'm like completely satisfied that all of the steps building up to it were um, were actually delivered and achieved. So I think you don't necessarily have to have in this use case, you don't have to have atomic verifiability, like because these are microtransactions. You could say like, all right, like take these steps, um, but eventually, if it's been faking all along, eventually it can't fake something that you ask it to do, and at that point, you say, "Oh man, I've gotten scammed by something, but I'm gonna mark it down on its reputation, and that's kind of good enough in a decentralized sense." In the same way that right now we're all used to doing that. Like I pay for some AI calculation, some AI inference. It comes back and it says, "Oh, like I did it, but I'm sorry I didn't do it." I'm like, "All right, well, I just lost a cent or 10 cents and let me try again." And if it happens too much, I just give up. But I've already uh, been happy to experiment along those lines. So I think my contribution is you probably don't need atomic verifiability because you know that people are going to be trying to do tasks that can be independently verified because they're interacting with the world and interacting with the real world. And that's quite different from, for example, downloading a file over BitTorrent, where once that data moves, you've got to pay for it or somehow, but then you don't care that if it ever does anything to impact the world ever again. So that seems like a different useful distinction.
Yeah, the discussion about verifiability for robots or validation for robots keeps coming up, but I haven't seen anything like a good solution to it. So, like one of the solution I had like was to use some sort of restaking solutions, but Rafa had like provided some counter arguments to that. I exactly don't remember, but like this is like a good problem to think about. Like, how do you verify if some AI or robot has done something? Any more thoughts?
Anurash, the thing that you've got me thinking about, which in this age of when you can just throw any of your LLM friends at something, could there be a fun like weekend when it was almost like, remember we used to have yakathons and a bunch of us were ready to help, and you would pick maybe 2 or 3 or 7 of these choices and just spin it up, throw a bunch of little robots at it and see which one, take notes and just kind of bench test everybody. Anyway, that's the way my brain goes. I'm curious if you think of things this way too.
Yeah, we could try it out. But like arranging something with the hardware in different parts of the world is like not that easy. We have only tried it once, maybe in 2021, right? When we had this Yakrova meeting over the weekend, and then we had the robots at different places. Uh, Maybe we can try it again now. But
Or
it's
you're right, in terms of time zones, regional might be the way to go. You know, you and I could connect easier
yeah,
than trying to include
yeah,
Eric in Japan, right?
yeah.
Sure. Yeah.
Okay, if there are no more thoughts, then we meet in 2 weeks. Thank you, everyone.
It was fun. Thanks.
Bye.
Thanks.